the sum of the vector forces. So we know that normal force is going up, weight force is going down, so we subtract the weight force from the normal force. Set 170 equal to the normal minus the weight, and then you solve for the normal and you get 1020.
Okay, thank you very much. I'm going to go ahead and take presenter role back.
All right.
Nicole just typed she's not able to hear anything. Could somebody kind of troubleshoot with her, give her some pointers of what you had to do to overcome that obstacle? Yes, I am recording this, not for any nefarious purpose, but for those people that had problems, they can go back and watch this. Okay. Any questions on that particular problem?
No.
Oh, okay. Michael, I didn't know you're so funny. That's awesome. Okay, we're going to the next problem. Again, watch the time, please. Let me know if I want. Okay, so next problem number 3. Okay, in problem number 3, we're looking at the exact same thing, except it's slightly different. There is an acceleration downward instead of upward. So it says upon reaching the top of the building, so it is moving upward, but then there's this acceleration downward, basically so that it can start to slow down. Okay, so you're going to draw a free body diagram, and then you're going to figure out how much force the floor is exerting. Okay, so I'm going to go ahead and mute you, and you can go ahead and begin. Okay, I'm going to hand it over to Mike here, if I can find him. Let's see, where are you at? This is hard. Let's see, where are you at here? Mike, maybe it'd be easier if you just requested it from me, because I'm not finding your name. Thank you. Okay, so this is number 3, I guess. Okay, so in this one, the thing was moving upward, but the acceleration is down, so it slows down. So tell us how you went about solving the problem then.
Well, first we started with the formula, acceleration equals force divided by mass. So the acceleration is downward 3 meters per second squared. So then we know it's 85 kilograms. We just solve for F net, has to equal 255 newtons. And since it's going downward, accelerating downward, I mean, the weight force has to be greater than the normal force. And we know what the weight force is already, that's 850. So to find the normal force, that would give us a net force of 255 down. We take 850 and subtract 255, and that gives us 595 newtons for the normal force.
Okay, any questions on that from anybody? Okay, I'm going to go ahead and take presenter role again. Thanks, Mike. Okay. I need to type one more thing to Nicole, because I think maybe she might be using her student computer.
Oh yeah, on those the screen works, but the audio doesn't.
Maybe that's her problem. Maybe that's why.
Yeah.
Okay, let's go ahead and go on to the next problem, number 4. Again, watching my time. Okay, for number 4. Now it says while the elevator is descending, so it's already moving downward, the cable suddenly breaks. What's the force of the floor on the man? So again, I'd like you to draw a free body diagram for the man and then figure out how much force the floor is providing to him. I'm going to give you a couple minutes and I'm going to mute everybody. Any volunteers who would be willing to present, if you could please text it in so I know. It'd be nice to have a different group. Dana said that he would if he could just explain via chat. I think I'm going to go ahead and do that because I think he can explain just through chat. That works. So I'm going to see if I can pass it to him. It looks like Dana's not able to present a role. Is maybe, oh, okay, here we go. Okay, so let's look at his chat. This would be interesting. Okay, so, all right, so first let's look at his free body diagram. He has a normal force up and a weight force down. Okay. And it looks like he calculated the net force to be 850 newtons because it's accelerating downward at, I think, 10 meters per second each second. Okay. Can you see what I'm doing? No, I can't really. I don't think, at least I can't see. I see you type the word "the" and ignore the writing. Look at the typed text. And I don't see any other typed text. Okay, so the net force on the object would be the 850 Newton weight minus the force exerted by the floor. Okay, that makes sense. So that would be equal to the 9.8 meters per second squared acceleration times the 850 kilogram weight or mass, right? Uh-oh, what's going on there? So, let's set this to equal, okay. So you're setting those two equal and solved, and what'd you get when you solved it for the support force? $17 newtons. I think I kind of agree with Connor. If you use 10 on one side, wouldn't you have to use 10 on the other side? Or it doesn't really matter. You could use 9.8 on one side and 9.8 on the other side.
You'd still get 0 either way.
Yeah, so you wouldn't get 17 newtons, you'd get 0. So, Dana, one last thing. One last thing. If you had to critique your free body diagram, what would you change about it? No normal force, right? Would be, yeah, it'd be much smaller. In fact, how small? There'd be none, right? Okay, any questions from anybody?
So
Philip.
that's just because it's falling and it's not touching anything else, right?
Right. So not only is the elevator in free fall, but so is the person inside of it. So is the elevator really supporting the person?
Not really.
No, they're not. They're kind of falling together, so there's no support force. Make sense?
Yep.
Okay. All right, I'm going to take presenter role back. Thanks, Dana. That was interesting experience.
Hello.
We've got about 10 minutes at most. Let's go ahead and move on to the next problem. Okay, for this one we have a 70-kilogram skydiver jumping out of an airplane, and immediately after they jump, you need to figure out how large the acceleration of the skydiver is. Again, what I'd like you to do is draw a free body diagram first to figure that out. Then it says upon reaching a downward velocity of 100 miles per hour, a 300 Newton drag resists the diver's motion. So when we say drag here, we're talking about air resistance. So again, you're going to draw another free body diagram and figure out what the acceleration of the skydiver is. Let me give you about 3 or 4 minutes to do that one. Okay, I'm going to have you guys come back, and Michael's group has volunteered, so I'm going to see if I can go ahead and pass it to him, or maybe he can request it. It might be faster. There we go. Okay, so for the skydiver, if you can kind of explain what you have there, anybody in Michael's group? Can anybody talk in Michael's group?
I can talk.
Okay. So in part A, the thing is, right afterwards, right after it jumps out of the airplane, what would the acceleration be, and how did you figure that out?
Well, he doesn't have a parachute or anything. There's not enough air resistance yet. He's basically in free fall, so that's just the number you use for that.
Okay, and then what about the second free body diagram? I see the drag down. Is
Oh,
that
yeah,
the only?
Never mind. There needs to be where's that?
Okay, so there's another force downward, right? There's a weight. So there's a drag upward and there's a weight force downward. Okay.
Okay, and that means the math we did is incorrect as well. So.
Well, could you do the math and force, or take us through the logic? Maybe write an equation for us.
Okay. That first part, F net equals m times a.
Well, actually, let me stop you for a second, Michael.
Times a is right. Yeah.
Let me stop you for a second. I think your free body diagram is a little bit misleading. Which force is going to be bigger, the drag force up or the weight force down?
The weight force down. I didn't have enough room to.
Yeah. Let's go ahead and make that longer. Okay, and then since it's longer, let's go ahead and write a net force equation. It's going to be F net equals what?
Just writing that right now.
Now, you got to you have to keep in mind you got to start with the bigger force, right? Yeah, there you go. Okay. Whoops. Okay. All right, and then could you go ahead and solve it for us? Okay, thank you. I kind of put you on the spot there, but that's exactly right. Does that make sense? Anybody have any questions about that?
Yeah, why is it not?
I'm kind of hearing somebody. Let me take. Actually, could you speak up a little bit or type it in? Okay, somebody had a question. I couldn't catch that question. Okay, Jessica, why is it not, okay, why is it not negative? Ah, okay, I didn't catch that before. Okay, so why is it not negative? Well, actually, the acceleration is downward, so if we wanted to add to this, I'm going to add on here. I'm going to see if I can take the mouse over here. We probably should say over here, oops, we probably should say meters per second squared. I can't do this. Meters per second downward. Of course now. But I don't know that I would say negative though, Jessica, because negative is helpful in the calculation, but it's not helpful in explaining which direction the acceleration is.
Okay, I got it.
Okay. Any other questions?
I'm trying to figure out why wouldn't it just be 10 meters a second squared? Because, you know, the pole of the Earth would always be the same.
Okay, except
Because of the resistance.
that's true. There's going to be a gravitational. We talked about this a little bit yesterday or the day before, depending on you know, which period you're in. But the gravitational field strength is still 10 newtons per kilogram. You're absolutely right. However, if you look at the free body diagram here, we have a drag force up of 300 newtons, and we have a weight force downward of 700 newtons. And so the net force is not going to be 700 newtons. If the net force was 700 newtons, then they would be accelerating downward, kind of like in the figure here of A. Now the net force is smaller. It's actually only 400 newtons, and so their acceleration isn't as much. So, Philip, if you were going skydiving and you want to live through the experience,
Yeah.
what do you want your acceleration to be right when you're touching down on the ground?
Not very much.
In fact, you want it to be what?
Close to 0.
That's right. I mean, you might be moving, but your acceleration is 0, okay?
Oh, yeah.
So how does the drag force from the parachute then compare to your weight?
It equals it out.
There you go. Right, exactly. It
Okay.
equals out. Any other questions? Thanks, Michael's group. Thank you very much. I'm going to take presenter role. How are we doing on time, guys? Oh, I think that's it for today. So I appreciate you guys kind of persisting along with this process. And please, if you haven't already, please email me the screenshots of your problems. In fact, I'm going to leave it connected here for a little bit, so if you want to retry your student computer to connect so you can actually send me screenshots, I really appreciate that. We need to keep those technology people on their toes. I mean, they gave you this piece of machine that's not working. We need to make it work for you guys. Okay, so you guys are welcome to leave. See you later. Bye.
Oh shoot! Is this the after party that we always have?
Yeah.
Hello?
Woo!
Mr.
You guys have-
Limpus is here this time.
You have an after party afterwards?
We always have an after party once you leave.
Wait a second. I didn't know you guys could still do that because I closed the meeting and it still goes on.
Yeah.
Well, we can still talk. We always chat after you close the meeting.
Is that right? That's weird.
It's awesome is what it is.
We can't text chat, like we can't type, we can only talk.
Except for Dana.
That's
Yeah.
interesting.
Mitch always creeps on us.
Who's that, Mitch?
He always listens.
Mitch is always listening.
How do you do screenshots? Michael asked, how do you do a screenshot? What you do, at least on my student computer, or my teacher computer, is I do function, and then it's almost in the upper right-hand corner. It says something PRT screen. So I do both of those, print screen, and then I could just paste them right into an email. If you don't have email, what you could do is you can save them to your desktop. You can open up a Paint program, and then you could just simply paste it right into that. And then I can save that to my desktop and then save that into a flash drive. I really appreciate you guys taking the effort of putting it on the flash drive and then emailing me, because we're not going to make these computers useful for you unless we start complaining about the problems.
Connor Kirk.
Anybody have any other questions for me? Okay, I'm going to leave. You guys keep on having fun. Okay.
After party.
You're missing out.
Oh, no, you know I'm recording this right now, right?